Hello guys, I want us to quickly look at how to use the multimeter. Before you can be able to use this instrument safely and effectively, there are a few things you should know that will help you to get your measurements correctly and also to protect yourself and the instrument during measurement. Okay, so as the name implies, a multimeter is a meter that is designed to be able to measure different electrical and electronic parameters such as voltage, current, resistance, and others. But in this video, we'll learn how to use the multimeter to measure DC voltage, AC voltage, current, and then continuity of a conductor or a wire. And then in another video, we'll be looking at how to measure resistance, diode, and other parameters. All right, so as you can see here, there are several parameters that this meter alone can be used to measure. For instance, starting from here, we can use this multimeter to measure capacitance. We can also use it to check a diode, and then we can also use it to check continuity of a conductor. All right, so we have the meter itself, and then we have the probes that will help us to do any measurement. When you look at the bottom of the instrument, there are 4 ports here. 1, 2, 3, 4. And then each of these ports have their own role that they play, depending on the quantity or the parameter you are measuring. But for clarity, for whatever measurement you are taking, the black lead always remains in the common port. Next to the common port, we have another port that is labeled with the symbols for voltage, resistance, and diode. What it simply means is that when measuring voltage or resistance or a diode, the second lead, which is red, will come here. These other 2 ports are for current measurement. If you are taking a measurement of current and then the amount of current that is being measured is very small, then this red lead will be plugged here for you to get the accurate amount of current that you want to measure. Now, when using this port, you must make sure that the current that you are expecting or the current that you are measuring is not more than 200 milliamp. 200 milliamp is 0.2 amps. So you should make sure that when your red probe is plugged into this slot, whatever current you are measuring should not be more than 200 milliamp. In case the current that you want to measure is more than 200 milliamps, then you would have to use this slot, because when you use this slot, you can measure up to 20 amp. And again, it means that this multimeter can only help you to measure current up to 20 amp. All right, so without spending much time, first of all, we will start by learning how to measure DC voltage. DC voltage simply means direct voltage. Okay, anytime we talk of DC voltage, we are talking of voltage that is produced from a battery or from a solar panel or from a DC generator. When measuring DC voltage, you have to set the selector switch to direct voltage on the multimeter. If you look here, there is a symbol for direct voltage. So here we can measure any voltage between 200 millivolts up to 1000 volts DC. Now, the amount of voltage you set the selector to here will depend on the amount of voltage you are expecting from the measurements you are taking. For instance, if I want to check the voltage of this battery, the first thing I have to check is the rated voltage of this battery. Okay, so here, this battery can produce up to 1.5 volts. And so I have to set the meter to anything that is a little above 1.5 volts. And so between 200 millivolts and 1000 volts, the value that is a little above 1.5 volts is 2 volts. So we turn the dial to 2 volts. That means we want to check the amount of voltage in this battery. Okay. Now, having done that, The next thing we have to do is to plug in the leads that we'll be using for the measurement. And so, as I mentioned earlier, the ports are labeled. Here we have common. Then the particular slot to choose here will depend on the parameter that you are measuring or the quantity that you are measuring. In this case, we are measuring voltage. And so if you look here, we have voltage here. So the next probe will plug into this slot. So with this, we are set to measure the voltage of this battery. You can see here that this is the negative of the battery, and then this is the positive. And so we use the black to touch the negative side, and then the red to touch the positive side. And for this battery, we have a reading of 1.484 volts. So it means we have a little drop. All right, so the next measurement we are going to take is AC voltage. And when measuring alternating voltage, the probes will still remain where they are, but then we'll have to change to AC voltage. This sign represents AC voltage. And in that column also, we can measure any voltage between 2 volts up to 750 volts. Now, the supply voltage I'm expecting here is 230 volts. And so on the scale, I will have to select a voltage value that is a little higher than 230 volts. But looking on the scale, we have 2 volts, 20 volts, 200 volts, and then 750 volts. So the only value here that is higher than 230 volts is 750 volts. And so I'll turn the dial to 750 volts. And in measuring voltage, we connect the probes across the supply. And so black will connect to neutral, and then red will connect to light. So here, black to black, and then red to light. So here, the value we have here is 227. 227 volts. Okay. And then you may want to check to be sure of the amount of voltage available at a socket or at a plug-in point so that you are sure there is enough voltage that can supply your appliance. And so in a 230 volt system, when you have your voltage around 227, you are very sure that if there is any problem that is causing an appliance not to work, that problem is actually not happening as a result of low voltage. So that is how to measure AC voltage. Then we move on to how to measure current. Before I move on, one thing you must always be careful about is to ensure that when doing your measurement, your hands do not touch the probes. All right, so before I continue with the current measurement, I have 2 multimeters here. I brought 2 just to remind you that though this instrument can take every measurement that this one can also take, the labeling and the inscriptions and then the design may differ. For instance, on the first one, we have our common terminal at the beginning. But here, our common terminal is the second slot. And so whenever you have a multimeter to use, you must first study the multimeter before you go ahead to do any measurement. All right. So for our current measurement, I want to use this particular instrument to take that measurement so that at least we'll have a feel of how to use different kinds of instruments correctly. Okay. All right, so for this one, you should look for common for your black probe. And here, we have it as the second slot. So you plug it here. So for the first measurement we took, which is the voltage, we would have plugged this one here. But now we are measuring current. So, as I mentioned earlier, you should also have an idea of the amount of current you are expecting from your measurement so that you can properly select the value on the scale. All right, so because we are measuring current, our next probe will come to either milliamp here or 20 amp here. When we plug it at this slot, then it means we are not expecting anything more than 200 milliamp. But if we are expecting a current more than 200 milliamp, then the best slot to use is this one. And we must also make sure that whatever current measurement we are taking will not exceed 20 amp. If it does, you end up destroying the instrument. And in a best case scenario, a fuse in this instrument will have to blow. And that situation must always be avoided. Okay, so here, this lamp is an incandescent lamp. For a filament lamp like this, you would have to use the 20 amp slot. And then what happens is, if you are taking the measurement and you realize that the reading that is showing on the screen is lower than 200 milliamps, then you will then move it to this slot so that you can get an accurate measurement. Okay, but if you plug it here and you take the measurement and then you are getting any amount of current that is higher than 200 milliamp, it simply tells you that if you should have plugged it here from the beginning, you would have blown a fuse in this instrument, which should always be avoided. So having set our meter, we now have to turn the dial to AC current. And then looking on the scale all round, we have our AC current here. Okay, and so we have a range from 20 milliamp up to 20 amp. So we can measure any ampere between 20 milliamp up to 20 amp. Okay, and so we turn the dial to 20 amp. With this setting, if we take our measurement and we have a current value that is above 200 milliamp, then that is a correct setting that we have done. But if we take the measurement and we have anything below 200 milliamps, then it means we would have to move this probe from here to this slot and then return the dial to 200 milliamp. Okay, but for the starting, it is always best and safe to select the highest ampere. If you are not really sure whether your ampere will be below 200 milliamp or not. For higher current measurement, we have the clamp-on ammeter that you can use to measure higher amounts of current. But with this type of multimeter, you can measure only up to 20 amp. And there are other multimeters that may not even be able to measure up to 20 ampere of current. And so it is always good to check to know what values your multimeter can safely measure. Okay, so now to measure the current, what we are going to do is that we'll first plug our blue wire to neutral. And then we will leave this end like this. Okay, so here our neutral is taken from the supply straight to the lamp, but then we would have to break this line, and for safety, I'll be using this switch so that I will take the measurement from this switch rather than taking it from the bare wire like this. So I'll connect this here. Then it means I will need another wire that will move from the switch to the supply. Okay. Okay, now our lamp is on. So now what we are looking at is that we want to know the amount of current that this lamp is consuming or that this lamp is taking to work. And for us to be able to do that, we first have to break the circuit and then place the meter in series with the circuit. So this switch has to go off, and then we'll now place the meter in series with the circuit. In series means that we connect one probe here and then the other probe comes to this terminal. So what is simply happening is that whatever current is going to the lamp will have to flow through the meter first. And so this is the amount of current that this lamp is taking to work, 0.42 amps. This is in amps. And so now you realize that if we had plugged our red probe here, we would have ended up blowing a fuse because the value we are measuring here is actually higher than 200 milliamps. 200 milliamps is about 0.2 amps. Now let's remove this lamp and use a LED lamp with a much lower wattage rating. And then let's see what will happen. Okay, so this is a LED lamp. This has a much lower wattage rating than the filament lamp that we used first. Okay, so let's see what happens. So neutral, right? And so you see that the reading we are having here is very low, much lower than 200 milliamps. Now, because we are having a value that is much lower than 200 milliamps, for us to be very sure that our measurement is accurate, we would have to move this probe from here to the milliamp place where we can measure up to 200 milliamp. Okay, and then we reverse this from 20 amp to 200 milliamp so that we can get a very accurate reading. So again, one probe and then another probe. So here we have our reading in milliamps and we have 36 milliamp. So this is the true value of the amount of current that is being used by this lamp. So you see that the first measurement we took was not accurate because this lamp requires much lower current than the setting that we did. Okay, and so if you don't know this trick, you would always be taking wrong measurements from your circuit. All right, so now we have done DC and AC voltage. We have done AC current. Now, when measuring DC current also, it is the same steps that are required, just that a DC current will be supplied from a DC source, which is usually from a battery. And so most of the time, for loads that are supplied from batteries, if the total current to the load is expected to be below 200 milliamp, then you set your probe to 200 milliamp, and then you set your dial to 200 milliamp. But this time, you would have to look for DC current, not AC current. So we would have to look around here, look for DC current, and then it is just around where the AC current is. So this is direct current. Okay, and so in case we are measuring direct current and we expect the total current to be less than 200 milliamp, then we turn the dial to 200 milliamp. Okay, if after taking the measurement, you realize that the reading you are obtaining or the reading you are getting is below 20 milliamp, then you may not get an accurate reading when you set the dial to 200 milliamp. So you would have to return the dial to 20 milliamp to get the accurate reading. Okay. All right, so the next thing we are going to do is actually a test that we can use the multimeter to do, and that is to check for continuity of a conductor. All right, so for instance, you expect this cord to supply power from a certain socket to a certain appliance. Now, when you connect this cord to the appliance doesn't work. And so one thing that can make the appliance not to work is if there is a break in any of the wires that connect these pins to the appliance. So obviously, for this cord to be able to supply power to your appliance, current should be able to flow from this pin to this socket, and then from here to here, and then from here to here for safety. So if you want to check if all the wires of this cord are continuous, if there is no break in them, we can also use the multimeter to do that, and that is what we call continuity test. Again, this is a cartridge fuse. You can also do this test to find out if this fuse is intact or if it has blown. Okay, so in doing the continuity test, we would have to change the slot here. If you look here, you can see a symbol like a sound wave. So we plug the red there, and then when you look on the scale also here, you can see the same sign. So here also, we turn the dial to that symbol. So what this simply means is that If the conductor is continuous, we'll hear a beep, ping, from the instrument. And then with this particular type, this red lamp will also show to tell that the fuse is intact or the cables in the cord are all continuous. All right, so let's start that. Before you start the test, you have to bridge the two probes. And if you bridge the two probes, you should hear the same sound that if your cables are good, you will hear, like this. Okay. All right, so here we have live here, and then we have live here. So if this connection is continuous, we should hear a beep, and then our red light is also on. Then let's check earth. So this is earth here, and then this is earth here. If this is also continuous, we should hear the same beep. Okay, so it means these lines are all continuous. Then, as I said, we can also use it to check the fuse. If the fuse is intact, we should hear the same beep. This shows that the fuse is intact. Okay. With the second multimeter, we expect the same sound. We expect the same result. All right, so this is the first part of this exercise. We'll continue to learn how to check other parameters with the multimeter in another video. All right, so thank you very much for watching this video. Please, if you have learned something from this video, share with your friends. And in case you have not yet subscribed, please do to stay connected. You can also check out on my other videos. I have a lot of educative videos that you will be very much interested in. And so please kindly do well to check them at my channel. Thank you very much again. See you in my next video.